I'm going to give 3 organic nomenclature examples. First thing you want to do is look for the longest chain. Doesn't have to go from left to right, it can be anywhere in the molecule. Here's one example for the longest chain. The other one would have that methyl group going down. And this one has 1, 2, 3, 4, 5, 6, 7, 8 carbons. And so the name here is going to be octane. You have 2 possibilities for the numbering. One is going to have numbering starting at the carbon on the bottom on the main chain, 1, 2, 3, 4, 5. So 5 ethyl, 7 methyl. The other way to do it would be to start with the numbering on the top, and that would make the methyl in the 2 position. So it would be 2 methyl. So it would be 1, 2, 3, 4 ethyl octane. And we're going to pick the lower one because the 2 and 4 are less than the 5 and 7. Okay, once you have the name, then you could easily go to the structural formula. So you write out 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. Then there's a methyl in the 2 position and a ethyl in the 4 position. Now you want to put the hydrogens in, 1, 2, 3, 4 on each carbon. Okay, I'll put the hydrogens in blue. And finally we could write out the molecular formula. Oh no, wait, we want to do the condensed formula next. So the condensed formula you write out the main chain and then put the substituent groups on it. So you'd say CH3, CH, and then you want to put the methyl group in parentheses. 3rd carbon is CH2, 4th carbon is CH, and then the ethyl group is in there, or attached. And the rest of it is just CH2, 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 and CH3. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 carbons. And then the hydrogens are 3, 4, 7, 9, 10, 15, 17, 19, 21, 24. So if you double the 11, you get 22, and add 2 and get 24. So that looks right for the saturated hydrocarbon. That would be the molecular formula. So in the end, then, we have the bond line formula, the name, the structural formula, the condensed formula, and the molecular formula. Alright, so then second example, the molecule is the same except it's going to have a double bond in there, which is going to change the numbering. So this is going to indicate, illustrate the numbering for the double bond. So example 2, and now we put a double bond here. So we're not going to be looking for methyl and ethyl and how to get the numbering for those substituent groups lowest. Instead, we're going to look at the double bond because that will dictate the numbering in the main chain. So the main chain is the same, right here. And the numbering on the main chain is going to be 2 for the double bond. So this is going to be an octene, a 2-octene. And once that's established, then the numbering is 1, 2, 3, 4, 5 ethyl, and 7 methyl. Octene. Next we could do the structural formula. Just look at the name. 1, 2, 3, 4, 5, 6, 7, 8. Double bond is in the 2 position. If you go from right to left, you could put it in the 2 position going left to right. That part doesn't matter. So it's 1, 2, 3, 4, 5 ethyl, and then 6, 7 methyl. Okay, then you want to put the hydrogens in. 1, 2, 3, 4. 1, 2, 3, 4. And then when the double bond is there, you got 2 in between the carbons and 1 to the left. So there's just 1 hydrogen needed, 1 hydrogen needed, and then over here you've got CH3. Put the hydrogens in. Oops, forgot these. Alright, so this should be, well, let's go ahead and do the condensed formula next. And we got 8 carbons in the main chain. CH3, CH, parentheses CH3 for the methyl group. Third carbon on the from the left is CH2. Fourth carbon is CH, and then the ethyl group is in there. CH3, CH2. Then you have CH2, and then for the double bond, CH, double bond, CH, and then CH3. Okay, that's the condensed formula. Then the molecular formula is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 carbons, hydrogens, 3, 4, 7, 9, 10, 15, 17, 18, 19, 22. So that is a CnH2n formula. So we have on the top the bond line formula, then we have the name, next we have the structural formula, below that is the condensed formula, and finally the molecular formula. Alright, and then the sample is this one. Okay, so that phenyl group will be a substituent group added to the main chain. The main chain has 1, 2, 3, 4, 5, 6, 7 carbons. So it's going to be a hept, and then it's got a triple bond, so it'll be heptine. And the position of the triple bond is in the second carbon. And so the numbering is set by the position of the triple bond. And then you have 1, 2, 3, 4, 5. The phenyl group will be in the 5 position. That's it. There's no other choice for the numbering because it's set by the triple bond. So here we could write the structural formula. Carbon, there's 1, 2, there's heptine, so it's 7. 1, 2, 3, 4, 5, 6, 7. Make the second carbon triple bond. And then the 1, 2, 3, 4, 5th position. Make that phenyl, which is the benzene ring. Okay, next we're going to put the hydrogens in. 1, 2, 3. 1, 2, 1, 2, 3, and then here's a hydrogen. And each on the benzene ring, you could do it this way with a circle, which means alternating single and double bonds. And I think I need to get rid of that hydrogen. Yeah, I do. So let me get rid of this hydrogen. If it were cyclohexane, you would not get rid of that hydrogen. Okay, so we can put the hydrogens in. Next, we could write out the condensed formula. So there's 7 carbons in the main chain. CH3, C, triple bond C, CH2, CH, and the benzene ring, which is C6H5, and then CH2, CH3, 1, 2, 3, 4, 5, 6, 7 on the main chain, right? Okay, and then finally the molecular formula is 1, 2, 3, 4, 5, 11, 12, 13, C13, H is 3, 5, 6, 11, 13, 16. So C16, count that, oh, wait a minute, that's a hydrogen. And that count doesn't look quite right. 3, 5, 6, 11, 13, and 16. So it would be, yeah, it doesn't seem to follow any formula because of the benzene ring that's present. Alright, so that would be the molecular formula.